Till September the 10th. Let's get started on the fourth problem of the section. So we are working on set modulo p to the eth. The multiplicative group has the order these are the multiply of p, which are not invertible, all right, and which are mapped to GL2. No, that's the mapping, the reduction modulo p, and then the kernel. So the unit element, of course, is so to all of these four elements, we can add any of these p to e minus first numbers. So that means the kernel. Now let's call it p. That's a silly name for projection. That's maybe not really a good name. So let's call it phi, the projection. So the kernel of phi we can insert any of these elements. So that means that the number of elements in it to the fourth and then the order of the group itself it's obviously onto, because we can just use the numbers, lift them to anything we want, and it's L and GL2. So we have the kernel, no, the image, and that's DL2. It's isomorphic. Modulo the kernel. And that means the number of elements equals the number of elements divided by the size of the kernel. And now, which do we know here? GL2 here, we did that in the last problem, which I have here. This was GL2, p to minus first squared p plus 1 equals the unknown divided by the number of elements in the kernel This was actually a surprisingly complicated result. My. It is actually of the order p to 4 e minus 3 eaten by those. So it has the right order of magnitude. So let's go with it. And then the special linear group. Oh, that was B. That's the trick we know. We take the map, the determinant, and it's obvious. That's actually not obviously onto. Oh yes, it is. We can have one with one in the diagonal, and then the result we want on the other point in the diagonal and the other vanishing. So it's onto. And this is the multiplicative group, so it is homomorphism. And it's not onto this guy, it's actually onto the multiplicative group, which we have here with these elements. So we need to determine the, now what do we need to do? Oh, the kernel is exactly the special linear group. And that means that the image is isomorphic to, let's write it correctly. Divided by the kernel. There we go. So that's the number of elements here. We have that there, up there. Equals, and the general linear group we have here. And this is the guy we want to find. And if I'm lucky, we are able to reduce this so that we can prove that the division actually is possible. I can't see that. Oops. Oh, maybe I can see it. That's like 3e minus 2. The denominator is just vanishing. My. I would really like to have a check on that.